Okay, so previously we discussed how the reservation station and the rename register allocation table work along with this machine. So now we are going to again look at the structure of this Tomasulo machine, the IBM 36091, and we're going to discuss another concept called the reorder buffer. And once we discuss these concepts, we are going to then discuss the overall Tomasulo algorithm. So this is the overall structure of the machine. So we know that there are these registers, and then there is this instruction queue. Then there is a common data bus which is connected to the reservation station and to the registers. We have not shown the reorder buffer yet, and we have not shown the uh, RAT in this structure. So let us first see broadly how the functionality of this machine is described. So broadly, they describe the functionality as three stages. The first one is called the issue stage. So there are different terminologies in modern machines and modern processors, but the terminology used in this Tomasulo machine is as follows. The first step is called the issue. So this covers the instruction fetch, wherein the instructions are fetched from the instruction unit to the instruction queue. So that is the fetch. They are fetched in order, that is first in, first out order. They're also decoded. So as part of this decode, they're next sent to a reservation station which is free. So if we go back to the previous slide, so if we have two reservation stations here, one corresponding to add and one set corresponding to multiply. So as and when you get the instructions, if you find the free reservation station, you send the instruction to that particular reservation station. So that is part of the decode step. So if there is no free reservation station, it is a structural hazard because the other instructions are using it, therefore we stall. If the operands are not available in the registers yet, it means that it is basically a data hazard, and therefore we are going to wait till the operands are available. So we keep track of those operands which will be produced by the functional unit. So that is the next step. And also, if the destination, if the register renaming is allowed, we are going to rename the destinations, and we are going to make the sources point to the renamed registers. Now, all of this is actually part of the issue step in this machine. As part of the execute is just executing the instructions in the functional unit. So the reservation station also plays a role. So it is, as we know, it is a buffer which is going to hold the instructions till the operands are available. So it is going to hold the instructions till the operands are available. And then as part of the execute stage, we are going to keep monitoring the CDB for operands. And as soon as the operands are available, we are going to issue the instructions to the functional units. And that is how we are going to avoid these raw hazards, or in fact, we're going to delay these raw hazards by waiting in the reservation station till the operands are available. And then we execute the instruction. Then the third step is the write back step, wherein the data is going to be written to the CDB, and from the CDB, it's going to get written to the registers and the reservation station. So if we do not have what is called the reorder buffer, we support out of order write back. That means we can write back instruction 2's result before we write back instruction 1 result. Now these are the steps that we know already. So now when you add what is called the reorder buffer, this is going to be the fourth stage of this machine. It is called the stage called commit. And then what is a reorder buffer? That's what we're going to discuss today in this lecture. So it is basically a circular queue with head and tail pointers. I'm going to be describing it in the next slide. So it is going to buffer the result until it is okay to put the result in the register file. So what do we mean by it is safe or okay? It means that we want to do an in order write back. And basically to do an in order write back, we are going to use this reorder buffer. And the reorder buffer is then going to send the data to the reservation station. So basically the CDB does not send it directly, but then we're going to send it through the reorder buffer. So we'll see how this whole thing works. So this is the structure of the machine with the reorder buffer. Okay, so before we go there, let me just correct what I just said. So we're going to send the data from the CDB to the reservation station as we did earlier. But the only correction or only difference is that we are not going to send the data from the CDB to the registers directly. So the CDB to the reservation station is still going to exist because that is going to help us speed up this process. But the connection from the CDB to the register file is not going to exist directly. So we're going to send the data from the CDB to the reorder buffer, which is then going to send it to the register file. So this is a small correction from what I just said. Okay, so we'll first see how the reorder buffer works, and then we're going to discuss the whole algorithm with the help of an example.